Hi guys, welcome back to another video of me teaching, and today I have this question on the board for you guys. So why don't we just get into question. What this question wants us to prove that this whole big thing or product is an integer, and we also want to find the sum of all prime factors of this big thing. Okay, so before we can solve this question, we first have to know some prerequisites for us to be able to solve this question. Now, what prerequisites should we need? Well, number one is we need prerequisites of Chebyshev polynomials of the first kind. So I'll just write it here. First kind Chebyshev polynomials. So Chebyshev polynomials of the first kind are looking for easy ways to expand cosine of n theta. And the function that does that is Tn of cosine theta. And this makes it equal to cosine of n theta. Now, before we get to any of the fancy stuff, I first have to tell you what are the main ways that we usually expand cosine of n theta. Or, to make it simpler, cosine of 3 theta. Well, number one, probably the most typical and fundamental, is using the cosine of a plus b identity. So in this case, cosine of 2 theta plus theta. And then we can expand everything, and usually this is quite easy. Now, for the second way is a bit more complex, and that is using De Moivre's theorem. So we see we first have cosine theta plus I sine theta, and we have to raise this to the power of 3, and using De Moivre's theorem, this is equal to cosine of 3 theta plus I sine of 3 theta. And then we can expand this using binomial expansion and separate the real and imaginary bits, and the real bits will just be cosine of 3 theta. And of course, the third way is using Chebyshev polynomials. So T3 of cosine theta. And I think that this objectively is the easiest way of doing. Okay, so now I will start deriving the first kind Chebyshev polynomials recurrence formula, which makes it so easy to calculate cosine of n theta. Okay, so I'll start off with this, and you might think that this has no relation to Chebyshev polynomials. I'll start off with cosine of n plus 1 theta adding cosine of n minus 1 theta. Now, I know what you're thinking. This has no relation to this. But now I will show you why it is related. So if you expand this, then it's quite easy to tell that all of the sine terms will get cancelled out. So the only terms left are the cosine terms, and there will be 2 sets of them. So 2 times cosine of n theta times cosine of theta. Okay, so, well now, since we know that Tn cosine theta is cosine of n theta, then we know that this first term will be Tn plus 1 cosine theta, right? Because it will be cosine of n plus 1 theta. This term will be Tn minus 1 of cosine theta. And this will be 2 times T1 cosine theta times Tn cosine theta. Okay, so since we know that these are all equivalent, then we must know that this term, Tn plus 1 cosine theta, is equal to this minus that. So what is this? Well, that is 2 times T1 of cosine theta is just cosine theta. So cosine theta multiplied by Tn of cosine theta minus this, Tn minus 1 cosine theta. Okay, and to make our lives easier, I'm just going to let cosine theta to be x. So then this recurrence equation will become Tn plus 1 of x is equal to 2 times cosine theta, which is x, Tn of x minus Tn minus 1 of x. So this is our final recurrence equation. And then I will give you some examples so we see how this actually works. Okay, so now that we have this recurrence equation on the side, I'll give you a few examples. Starting from the simplest, T0 of cosine theta, which is equal to T0 of x, and that is equal to cosine of 0 theta, which is cosine of 0, which is 1. Next, T1 of cosine theta, which is equal to T1 of x, is equal to cosine theta. Okay, so now I'm actually not going to write something cosine theta because we already know that it's x, right? So I'll just write T2 of x. So since this is a recurrence equation, then with only the first two terms, we can figure out all other terms. So using this recurrence formula, we see that T2x will be 2x times Tnx, which is this, so times x, and this is equal to x, by the way, sorry I didn't write. And then we subtract Tn minus 1, which is T0, so minus 1, equals to 2x squared minus 1. And if you keep writing, then for this question, we will have to use T7 of x. Okay, so this is what T7 of x will look like. So now I'll put this on the side and we can start actually solving the question. Okay, so now that we have both of these things to the side, then we see our actual thing, S. Now, this thing is a product of 35 terms. Don't you think that's a little bit complicated for you? Well, it is for me. Okay, so we want to kind of make this easier for ourselves. And how do we do that? Well, in most of my videos, what I say is we just have to watch. Let's see, the first term, if we ignore the square, we have cosine of 2k pi over 5, right? Okay, now, actually, I'll write this a bit lower. So I'll write it here. Cosine of 2k pi over 5. And this is equal to, when k starts from 0, this will be cosine of 0. Then it'll be cosine of k is 1, 2 pi over 5. Then it will go all the way until 8 pi over 5. Because once it reaches 10 pi over 5, then it'll repeat back here. So all the way until cosine of 8 pi over 5, and then it will repeat. Now from here, k went from 0 to 4. So 0, 1, 2, 3, and 4. Now, if we look at the second term, cosine of 2k pi over 7, this will also start from cosine of 0, because that is when k is 0. And then it'll be cosine of 2 pi over 7, and it will go all the way until 12 pi over 7, because once it reaches 14 pi over 7, it'll repeat back to cosine 0. So cosine of 12 pi over 7, and then it will repeat. And this is when k goes from 0 all the way to 6. Now, this is where our second prerequisite comes in. Okay, and what this prerequisite is CRT, or China Remainder Theorem. So, usually we have a system of congruence equations, and usually there will be more than two, but in our scenario, we will only have two congruence equations. First one will be x is congruent to a mod 5, and the second one will be x is congruent to b mod 7. Okay, and you have watched, and if you have watched one of my previous videos all about CRT, then you will know that x will have an only solution in mod 35. Okay, sounds good, but what does this have to do with the question? So this means that for every solution that x has in mod 35, this k, which ranges from 0 to 4 and 0 to 6, will cover all possible values from 0 all the way up to 34. Now, why is that significant? Because look, our original product ranges from 0 to 34. And do you remember at the start when I said 35 terms multiplying together is a bit too complicated? Well, now we can make it into two separate products, one of them ranging from 0 to 4 and the other ranging from 0 to 6. And that makes it much, much simpler. Okay, so our S will just become the product when S goes from 0 to 4, and we have the product when T goes from 0 to 6. And don't be scared that we have this many parameters. I'll make it simpler later in the video. And then we have, in the inside, I will just expand that. So we have 4 cosine squared 2k pi over 5. And we add 4 cosine squared 2k pi over 7. Okay, so now it seems like dealing with two products and two terms at the same time is a bit too complicated. So what I'm going to do is I'm going to mainly focus on the inner terms, which is this and this. And I will try my best to ignore this and this. But how can we possibly ignore this? It's such a big chunk, right? Well, what we can do is we can just make this into some variable, x. So now that we have ignored this, then the rest will just be a polynomial, p of x. So this p of x will be equal to, actually, I'm going to write it here. This p of x will be equal to the product when t goes from 0 to 6 of this x plus this. So now we've made it much simpler, right? Now we only have to deal with 7 terms multiplying together instead of 35. And now this will be the end of part 1. And in part 2, I will start figuring out what this polynomial is using our Chebyshev identities. And so after that, we can figure out and solve this question. Okay, so thank you guys so much for watching. And if you enjoy my video and you want more videos like this, please consider liking and subscribing. If you want to master something, teach it.